Welcome back. You are in lesson 6 of the module 5 of the machine learning course with Python 3. The course is conducted by Subraj Academy. This lesson we are going to look at agglomerative clustering. Agglomerative. The bottom up. The initial groups or objects are the leaves. All the data points or feature vectors are the leaves. Every time two groups are merged, join them in the tree. How do you measure the two groups? The distance between them should be smallest. And the height of the branches represent the dissimilarity between the groups. What is dissimilarity? The Euclidean distance between the two data points or two clusters. The root contains all the data. If we compute the number of steps in the algorithm, there are big O n steps. And the big O n cube is the total running time or computing time. So it's a very complex algorithm. So now I explain to you the flowchart. With the flowchart, the agglomerative algorithm. So you start objects and their measured features. You have the objects, okay, and the locations where the objects are located. So convert all object features into a distance matrix. Set each object as a cluster. If you have n objects, you have n clusters at the beginning. Repeat until number of clusters is only 1. How do you do it? You keep on merging two closest clusters and updating distance matrix. So this process will finally lead you to a single cluster with n nodes at the root. There are many variants of agglomerative clustering, which is bottom up, you know it. So there are many variants. One is the single link clustering, second is the complete link clustering, third is average link clustering, and the fourth is word linkage. And they are simple, although the names may look, it may frighten you, but it's not that difficult to understand. The first one is single link clustering, agglomerative clustering. They are also called nearest neighbor clustering. The distance between two groups, G and H, so these are the two clusters. You know the distance between two clusters, G and H, is defined as the distance between two closest members of the group. You don't take A to D or A to C, okay, or B to D, the nearest distance. The distance between two groups, G and H, is defined as the distance between two closest members of the group. The tree is built is the minimum spanning tree. Is the minimum spanning tree you will get if you do the single link clustering. We can represent single link clustering, we can implement single link clustering in big O n square. This is how, if you do carry out the single link clustering, you will get like this. The dendrogram of a agglomerative clustering is something for a particular data set. It may vary from data set to data set. Capture this in your mind. I'm going to show you the other type of clustering also. So that may give a different type of diagram, different variation in the diagram. It may look different. The second type is complete link. This is also called furthest nearest neighbor cluster. That was nearest, this is furthest. So distance between two groups G and H is defined as distance between two most distant pairs. Got it? Easy to understand. A to D is the largest distance. Producer clustering with smaller diameter, compact. Producer clustering with smaller diameter. We can implement this in O n cube. See the other one O n square, the single link, and this is complete link, the O n cube. So it looks different. See, look at this and look at this. There's a lot of difference. So this looks better, I think, complete link, but it takes more time. The third type is average link. Is the preferred method. Measures the average distance between all the pairs. So there are four distances: A to C, A to D, B to C, B to D, between two clusters. We average them. Okay, you average them. Then you get the average distance. Using that, you carry out clustering. Represent cooperation with a single and complete link tends to produce relatively compact clusters. The problem is varies with monotonic transformation. Change in measurement scale changes the result. So the average link, if we change the measurement scale, it will change the results. That's why I'm telling you should carry out feature scaling compulsorily. So this is how the clustering looks like. And the fourth type, which I've already used when we are talking about dendrograms, we use the WAD. WAD's method minimizes the variance within each cluster. There will be variations within each cluster, so they are minimized. It calculates the sum of square differences between each point and the center of the cluster, and merges the cluster that result in the smallest increase in overall variance. So this is what we have used. It's also a very popular methodology. This is what we used in the previous lesson when we discussed about dendrogram. So let me give an example of agglomerative algorithm. So these are the points A to A, B, D, F, C. They're all the same old points. X1 and X2 are given here. So look at this matrix. There are 7 points. 7 points. A to A will be 0, B to B will be 0. All diagonals will be 0. And A to B, you calculate by using the equivalent distance, 0.71. Okay, and A to C is 5.66, and so on. E to F is 1.32. So likewise, 1.12. Yeah. So this way you calculate the distance between interpair distance by using equilibrium distance. So now we can make the two closest clusters. In the first iteration, which is the most closest? Is it A to B or DTF? So DTF is 1. DTF is 0.5. So first you take DTF. Okay, you merge DTF. It becomes a single node. Then, calculate the distance between all of them in the interpath A to B, A to C, A to DTF, A to E, etc. So update the distance matrix. Okay, you update distance matrix. This is updated distance matrix. Okay, we are using single linkage coverage, single linkage clustering. So what is the lowest now? A to B is lowest. Isn't it? That's the lowest. I don't find anything else there. Now we can merge A and B. So after that, we update the distance. AB, DF already found. We update the distance. What is the lowest? E. DTF and E. That the lowest. So you will combine this. Update the distance. Update it. Okay. So this way, keep updating, keep joining, and finally you will get the clusters like this. Now these two can be also combined. This is the final result, meeting termination of condition. We got a single cluster. So what we saw was agglomerative. The other is top-down clustering, which is divisive clustering. It's called divisive clustering. You start with all the data in single cluster, recursively divide each cluster into two daughter clusters. So group of n item, it's difficult to split n item into two groups. Rather, you can use k-means or k-medoids. So, two popular methodologies are agglomerative clustering, three popular, k-means, k-medoids, and agglomerative. These are three popular clustering techniques. In the agglomerative, there are four variations. You could choose according to your data. Now, I'm going to implement agglomerative clustering. I'm going to implement two types of agglomerative clustering. So, let's get into Jupyter Notebook. Okay. Let's take the first one. Agglomerative clustering. We are going to use average link clustering. Okay, all those are same. Import all the libraries. And the tail gives you there are 200 items. And we are going to cluster two features vectors, average income and spending score. So if you look at this, it's a two-dimensional vector with two columns. The first 5 elements are like this. So since they are, you must do feature scaling. So I'm doing the feature scaling and printing the x values. Okay, now I'm going to cluster agglomerative clustering. So from sklearn cluster import agglomerative clustering. We are going to do average link clustering. Cluster is equal to the object cluster is equal to agglomerative clustering. N cluster is equal to 3. Linkage is average. And clusters dot fit. So that makes the cluster. You can get the labels of the clusters, that is which each data point to which cluster it is joined. So labels, you get labels equal to clustering labels. And you can print the labels. Then you can also plot the clusters. Plot scatter x0. There are two feature vectors, so x0 and x1. C is equal to labels. C map is equal to values. Y labels the spending score x0. Y label is the spend X table annual income on Y label is spending score. The plot of the title is agglomerative clustering, average linkage, and show the plot. So first you get the labels. So all these are cluster 0. Then there are some in 1 and 2. So this is cluster 0, cluster 1 and cluster 2. Annual income and spending score. So all those, they are all lower annual income. Irrespective of spending score, I put one cluster. And annual income is low and the spending score is low, you get another cluster. Annual income is high and the spending score is high, you get another cluster. So 3 clusters you got, and that is the labels are here. Now we can draw the dendrogram also. That will give you a better picture, right? Run it. So you got dendrogram. He basically is getting 3. We said 3. So cut it here. So this dendrogram, it looks like this. This is for average link clustering. So this is the 3 clusters. And this is the dendrogram. Let me try to make it 4. Let's see what happens. N clusters is equal to 4. Let's see. I mean, of course, you can already determine from the dendrogram what will be the, but you try to with 4, what happens? So 0 to 3, so 4 clusters. So 1, 2, 3, 4. This is better. So if you cut it, where will you cut? You will cut here. You can cut here. When you cut here, it will be. If you cut here, you can't cut really here. You get only 2. But if you cut here, 1, 2, 3, 1. If you cut here, 1, 2, 3. And maybe 4. 3 is the right thing actually. 4 will be, maybe if we cut here, so 2 here, 3 here, 4 here. Okay. So anyway, maybe, 3 is the right one. Let me put pi, just to demonstrate to you, I put 5, number of places, n plus is equal to 5, and I want to show you how it looks like. Oh, see, very complicated, huh? So, where are the clusters? 1, 2, there's a cluster. It's not good. Actually, 3 is the right one. So this is average link clustering. So 3 is good. Okay. So now let me take another example of complete linkage clustering. Only one change I'll make from average and put complete. This stuff we already done. Which scaling we already done. And I've changed it to complete here, complete linkage here. Okay. So this is the clusters, 3 clusters no? Again. There might be little variations here. So this is how the dendrogram looks. I would like to do it SC2, I'll do also the dendrogram you see. This is SC2, this is average link, and this is complete link. So the shape changes. Shape changes, see? So I explained to you how to build agglomerative clustering with 2 types of linkage. One is complete linkage and other is average linkage. So that's all for this lesson, and this completes this module also. Go through the slides, carry out the exercises in Jupyter Notebook till you become confident. Okay, whenever you have doubt in the commands, you can Google it. Okay, or you can check with ChatGPT. Thank you for watching. Until we meet again. Bye bye.